Hey guys, today we're going to learn about how to export another workspace and be able to run Somatic short variant discovery pipelines. So I'm at the GATK best practices website. So over here it shows um, how the entire workflow is going. So basically you have like a BAM file, which you normally have a tumor and then a normal BOM file. Then you create a panel of normals. You use Mutect2 to do that. And then you use Mutect2 also to be able to call the somatic variants, that's SNV and Indels actually. There are some QC steps and some other steps involved. But then in Terra, you could incorporate all the steps in your workflow and be able to functionally annotate the variants with Funko data, and then you finish. Right, so there are links to the Terra workspace. What I'm going to do is to click here. So two steps. I mean, first, you need to create a panel of normals, and then the other one, you'll be able to use it to call the somatic mutation. So let's try this first. Creation of panel of normals. Let's me to sign in. Okay. Like the fingerprints. Very convenient. Okay, right. So this is where it brings us. So this is the workspace. You're looking at this dashboard. It gives some little explanation. I explain you could actually edit this. So what I'm going to do is to export this workspace. Sorry, is to clone this workspace. And then I'll call it Charles. Someone needs to pay. Thanks to my supervisor for the help. Then you clone the workspace like this. It should take some time. All right, so now we've cloned the workspace. We have a copy. This is our copy of the workspace. We can see the data. All right, so these are the BOM files, the individual BOM files. Over here, the BOM index, and so forth. If you go to the workflows, you get to see the other workflows as well. So the first step is to create a panel of normals. So you click the panel of normals. I'm sure because you exported also, you've also exported, like imported, you know, because we clone, we've also, imported some of the attributes, like the GATK Docker, Nomad, sample ID, so on and so forth. If you're working on your own data, you need to change this, but so what we're going to do, it works on the sample set. We're just going to select a few. Okay, all right, so we're going to run on this. Okay, we're going to call it panel. Okay, what we could also do is that we could, okay, all right, yeah, okay. And then we're going to delete intermediate outputs because we don't want like lots of intermediary files to be created, which is going to eat up our space. And then afterwards, we press analyze, run analysis, which will cause it to run. So it's going to run. It's probably going to take some time. Yeah, so it's submitted. It's going to run. So while it's running, let me show you how to be able to view BOM files. So there are about 26 samples, 26 BOM files. If you want to view these two BOM files on IGV, select them, right? So 2 rows selected, and you go to open with, then go to IGV, and then select these 2 files you see. And then we are using the reference B37 or HG19. So you make sure the reference matches what was used to align with. And then bingo, we have IGV, there are 2 BAM files. Now you could zoom in by clicking, like, double clicking, or you could even type in like specific genes like, TB53, and you search for TB53. Let's see whether something pops up when we narrow down to, right. So this is beautiful. So this is similar to what you find on like a normal IGV desktop, this TB53 region, right? You see the reads, right, which are aligned to the various exonic regions or the exons. Now what we could do is to also zoom in more. Double click and zoom, right? Yeah, you can zoom. We can also save as SUV, right? So it takes like a snapshot. We could also do as a guide. So we do something like this. Right, so if we see something, we could use this to guide us, right? So to go down and go out without losing alignment, right? Then we can also do center line. So maybe we are interested in, we want to see whether this occurs, this is captured in all the reads. Let's see whether this is captured in all the reads. So yeah, let me click the center line. Okay, now let's zoom in. See, there you go. See all this. Capture this. Zoom out a little bit. All right, so you can see it's only on, let's see, one read. It's not represented in all the reads. So I mean, this is more likely to be spurious. Yeah, it's more likely. Normally, it gets like variance at the edges of the reads, and less represented. It's you have little confidence of searching this. Okay, now let's put the center line on something else. You could see there's some gaps here. Let's see what we could find. Let's see what it is. Let's see whether these are common phenomenon. You can see cross samples, cross the reads. More likely, yeah. So we are basically evaluating the reads to see whether the variants are represented in more reads. See this. See? I mean, though it's also at the edge of some of the reads, but you could see it's represented in a lot of the reads. So that's why you could use the center line for. So you could search chromosomes, you could search genes, and that's it. You could also give the track names. You could also um, remove a track. So maybe you want to remove this. Maybe the down one you could remove. I think we should do that last. But what I want to do is to track heights. Yeah. So maybe I'm more interested in this. I want to increase the height. 700. Let's see, we'll get track heights will be a little more over here. Then maybe you want to reduce it to 300 back. Be able to view the two BOM files together in IGV. We could do that. Now, if you want to remove the bottom BOM file completely, remove the track, and it's gone. Yeah, and you could go back to your table after doing all your evaluation of the reads in IGV. So this is a really cool feature of being able to view actual BOM files on IGV and be able to um, vouch for some of the um, variants that you see. Now let's see what our job is still running. So it's submitted and it's still running. Let's see. So it's creating a panel of normals. Now we could view the status of our job. Oops, need to authenticate. Yeah, I think this would be better if I use Google Chrome. Yeah. Yeah, so it's running. All right, so let's see. 16 shards. Yeah. Oh, cool. Yeah, so it's running. We'll come back to it later and see whether it's finished. So when it finishes, we can run, Mutect2. Or we could even, go ahead with it. So the next step is to run Mutect2, and to do that, you click on the second workspace. Sorry, the second workflow. You could choose your version of GATK Docker. So you're working with pairs. So since we clone the workspace, we have all the data and everything, so we don't need to change anything. In your own data sets, you need to select your data in the table. Yeah, I don't think you need to change anything. And then, yeah, you have all the attributes, your reference data files, your FASTQ, sorry, your dictionary files, your FASTA files, and your FASTA index files. If you want to divide your jobs into pieces to let it run very fast, you could use the scatter count. You could assign a table reads, index, so on and so forth. You could do the OXOG filters. You could run the phone data also, and then you run analysis when you are done launch. Yeah. There is also Jupyter Notebook for you to play around with, which I think is also a cool way of learning. Yeah. And that ends it for variance calling, semantic variance calling, and viewing BOM files in IGV. Thank you.